Tired of the same boring routine day after day? Wishing there was a way you could avoid doing the same tasks again and again? Introducing Loops, the amazing new tool that takes away the pain of repeated tasks. You'll be amazed as Loops take away the drudgery of your programming and free up your time to work on more interesting stuff. Here's how it works. You describe the task you want to do, just one time. You get the loop started, and you tell it when to stop. And presto! The loop keeps doing your work for you as often as you want. It can go on forever. But wait, act now and you'll get a second loop, letting you choose exactly how many times you want to repeat the same task. That's 2 loops. So, let Loops take over for you all those boring tasks you've been doing over and over. Yes, in programming, laziness is a virtue. For programmers, being lazy means that you don't want to do tedious or repetitive work. So you look for a simpler, easier approach, in which you avoid repetition. With Loops, we take our first big step toward not repeating ourselves. And the most basic loop structure is the while loop. A while loop is the same thing as an if-then statement that's repeated over and over. In fact, when we write a while loop, we write it just like an if-then statement. All we do is replace the word if with the word while. An if statement starts with the word if, then has a conditional that can be true or false, then a colon, and then a body that's indented in. The indented part of that code is the stuff that happens if the condition was true. So, our code here checks whether some value is 0 or negative, and if it is, it asks a person to input a positive value instead. But what happens if we run this through and the person again enters a number that's not positive? Well, the code just goes on, accepting that wrong entry. We would have to add in another check after the first one, and then check that one, and so on. And if someone was stubborn enough, they could just keep entering negative values, and we'd eventually run out of if statements. But there's a really easy way to fix all of this, and that's with our while loop. With the while loop, we have the exact same structure as before, but now we've just changed that word if to a while. All the rest of the statement is the same. We have a condition, followed by a colon, followed by the code we want to execute indented in. And the main difference here is that with the while statement, we're going to keep doing this stuff in the body as long as the condition is true, without needing to type in all of those if statements. While sets up a loop that is like an indefinitely long string of ifs. Let's see how it works for the example we've been looking at. When we come to this while statement, we'll first check the condition, just like we did before with the if statement. If the condition is true, we do the stuff in the body, and if not, we skip it. So, what if we have a negative value, such as -1? When our code reaches this line, we find that the value is indeed less than or equal to 0, so the condition is true. So we run the indented line, where we ask for a positive value and get a new value from the user. But say the user is stubborn, or is just ignoring the command, and enters another negative number, like -5. The new number entered updates the value in memory. With the while statement, once we finish the body of the code, we go back and check the condition again. In this case, the value is still negative, so we run the body of the loop again. The user could, yet again, not enter a positive value. When we check the condition, it's still true, so we do the loop again. Our program can continue this indefinitely, until the user finally gets the idea and enters a positive value. Now, when we check our condition, finally, when they've entered a positive value, it's false, and so we skip the loop and go on to the code after the loop. Let's look at a slightly modified version of this loop. Just like with the if statement, we can have multiple lines of code in the body of the loop, the indented part. In this case, let's say we have 2 lines, an input and a print. Now, let's see what happens here. We come along to the while statement, and we have a negative value, so the condition is true. Because of that, we ask the user for input. Say the user enters the value 3, a positive value. What do you think happens next? Notice that the condition for the loop is no longer true, but we still have 1 line left in the body. Well, the right answer is that we continue with the body. We go on to the next line of the body, which prints the value that we put in just now. Notice we only check the condition again after we've gone through the whole body. Once we've started running the body of the loop, we don't check our condition again until the body of the loop is finished. It doesn't matter if the condition of the loop becomes false somewhere in the middle of the loop, we only care about whether it's true or false at the end. Let's look at another example. For once, this is one I do not want you to type on your own into your computer, at least not just yet. For now, just think about it. In this loop, we set the value to 0 and output the data. What will happen here? Notice that in this case, the condition is always going to be true. Inside the loop, we set the value to 0. And so every time we check the condition, value less than or equal to 0, it's going to be true. If we run this code, assuming the value wasn't positive to begin with, it's going to just write the value is 0 over and over and over. We can never get out of the loop. We refer to this as an infinite loop, and it's something that we usually want to avoid. But it's actually a pretty common bug. As you keep writing code, I guarantee that you'll accidentally create an infinite loop at some point. Now, because of this, you want to make sure that you know how to stop a program that's in an infinite loop. If you're running your code in the PyCharm or another integrated development environment, you'll probably have some sort of stop button. It's usually designated by a red square. Pressing this will stop the loop. Other times, you'll need to stop the program another way, such as by closing the window it's running in, or entering some command that will cause the program to quit. On Windows machine, that's often Control-C. On a Mac, it might be Control-Command-C. Okay, now would be a good time for you to try entering this on your own. You can enter your own simple loop, like the one you see here, that would cause the computer to keep on sending me the same message forever. That's right, if you ever feel you need a pick-me-up message, you can get your computer to give you unlimited positive reinforcement. Once you've entered this program and tried running it, you can practice stopping the code. Let's look to see whether or not this next example will cause an infinite loop. Here's one loop. The loop's condition is that the value is greater than 0. The first time we get to the loop, value is 3. So obviously the body of the loop will be reached. In the body, we have a couple of print statements, but in between we first set the value to -3, a value that's negative. Since the loop condition is that the value is positive, does this end the loop right away? No, the loop will continue. Remember that we only check the condition at the end of the body. So, later in the body, we set the value to 7. It's once again greater than 0. So when we get to the end of the body, does the body of the loop run again, or do we exit? Well, the body will run again. When we reach the end of the body, we'll check the condition, and since the value at that time is greater than 0, the condition is true, and so we run the body again. In fact, since the value will always be greater than 0 at the end of the loop, we'll always run the body again. That is, we're in an infinite loop. Of course, we normally want to avoid infinite loops, so let's take a look at a more typical loop. Suppose we have a variable a that we initialize to 0. We then have a loop that repeats as long as a is less than 3. Within the loop, we print out a and increment it by 1. So, what do you think the output here will be? Okay, let's trace through this example. We start out by assigning 0 to variable a. We then reach the while statement, and we need to examine the condition. In this case, we check whether a is less than 3, which is true, so we go into the body. The first thing we do in the body is print out the value of a, or 0 in this case. The next line of the body increases the value of a by 1. Since it was 0, now it's 1. At this point, we check our condition again. 1 is indeed less than 3, so we'll go through the body of the loop again. We print out a, and increment a by 1 again. Now the value of a is 2. Again, we check our condition, which is still true, since 2 is less than 3. We print out the value of a, and increment by 1 again. Now, when we check the value of a, the condition is false. A is equal to 3, and so it's no longer less than 3. So we're done with the loop. Notice that we've had values ranging from 0 to 2. After the loop is over, the value is equal to 3. By the way, one time through a loop is called an iteration. Here's one more example. Take a look at this code. What do you think would be printed by running this code? In this case, we'll print the values from 10 down to 1. When we start the loop, our value, 10, is greater than 0, so we execute the body. That will print 10 and then lower the value to 9. Since the value is still above 0, we do the loop again, so we print 9 and then lower the value to 8. This continues until we print 1 and lower the value to 0. Since the value is no longer greater than 0, we'll stop and not go through the loop again. There are many times when we program that we want to go over a range of numbers. So this technique of increasing or decreasing a value by 1 on every iteration is actually really common. It might be that we're counting something, so we want to increase the number by a fixed amount each time. Let's say that we want to find the ages of all the people in a group, for instance. We can count the number of people in the group, and then we can go through a loop that same number of times. Let's take a look at this example and see if you can follow what's happening, and then we'll trace through it together. In the first line, we find out how many people there are in the group by asking the user. The next line set up our counter for the number of people, I, and the sum of the ages in the group, which we initialize to 0. We're going to add up all the ages and then divide by the number of people. Now, it's good to pick variable names that make sense, something that tells you what that variable is doing. Calling our variable I might look like an exception, but actually this does make sense. You're counting through integers, and after all, I often appears just like this in mathematics, designating that some sort of iteration or indexing is going on. So whenever you're counting through a loop like this, it's common practice to call a variable I. It just means that you're iterating or counting through an index. In fact, if there need to be nested loops, where there's one counting loop inside of another, then it's common to use J for counting through the inner loop. Okay, back to our code. The next line that we encounter begins a loop. You'll see that the loop's a lot like the one we saw earlier, where we go through the loop one time per person. Inside the loop, we're going to ask for the age of the person, and add that age to the total. Notice that the message we print out has the person number in there. You might want to look at that input statement for a minute to understand what it's producing, or type it in and try it out yourself. Notice that we're asking for person I plus 1, since otherwise we'd be asking for person 0 first, which will be confusing to most users. Okay, finally, after the loop is over, we compute the average age by dividing the total by the number of people, and then output it. Let's get a quick run through. If we run this program, enter in 3 people, and the age is 10, 30, and 20, we find the average age is 20. This type of loop, where we increment some value by 1 on every iteration, is really common. In fact, because it's so common, there's actually a Python command specifically built to accommodate this type of loop. It's called a for loop. In terms of how the commands are written, the for loop is just a simpler way of writing a particular version of while loop. However, in practice, these two types of loops are used very differently. A while loop is used when we're not sure how many times we're going to need to iterate through the loop. A for loop is used when we have a precise set of things to loop through, or we know exactly how many times we want to iterate. We've just been looking at loops like the one you see here. We have some variable, which we call an iterator, that gets initialized to some starting value. It gets incremented every time through the loop, and it gets checked until it reaches some maximum value. In this example, our iterator I is initialized to 0, and then we take on the values 0 through n-1 as we go through the loop. We can write this same loop using a for loop, like you see here. These two loops do the exact same thing. The iterator I is still going to take on the values 0 through n-1 as we go through the loop. We start with the word for. We then give the iterator variable we want to use, which is I in this case. Then we have the word in, and then we have the range, followed by a colon. There are actually things we can put here at the end besides range, but we'll see those later. For instance, if we have for I in range 4, the values 0 through 3 will be printed out. Now, the range command actually gives us a little more control. Let's look back at our while statement. There are actually 3 things we can vary in the statement. First, there's the starting value, which is 0 in this case. Then there's the number that we're comparing to, which is n. And finally, there's the amount we increment by every step, which in this case is 1. We actually have control over all three of these things in the range statement. We can specify the starting value, the value we don't want to meet or exceed, and the amount we want to increase by on each iteration. If we list only one value in the parentheses, it's assumed that we start at 0 and increment by 1, not exceeding the value that's in the parentheses. If we list two values in the parentheses, it's assumed that we increment by 1, starting from the first value and not exceeding the second value. And finally, if there are three numbers, they give the three pieces of information: starting value, limit, and increment amount. So, look at this example. What should this be printing? This should print out the numbers from 0 to 6. We started at 0, checked on each iteration whether or not we were less than 7, and incremented by 1. Now look at this example. What would it output? In this case, we start at 1. We go up by 2 each time, and we only do this as long as we're less than 7. So, we would output 1, 3, and 5. I'd really suggest taking some time right now to test this out yourself. This is a really simple loop, just 2 lines. Try lots of variations until you understand what's going on. For loops can get more complicated, and you can see some of them may be unexpected behavior if you try putting in negative numbers. Really, go ahead and put some negative numbers in and see what happens. For example, look at this case and see if you can figure out what it does. This actually counts down from 5 and stops once we're no longer greater than 1. Notice that Python automatically tells that you're counting down when it sees the negative value in the third spot of the range. This for loop is the same as the one you see here. A key difference is that it repeats based on a greater than comparison instead of the less than comparison that we were using earlier. Again, let me encourage you to try this out on your own before going forward. Let's look at a couple more issues related to loops. First, let's go all the way back to where we started this discussion, the if statement. Here's the if statement that we were looking at before. Remember that we turned it into a loop by replacing the if with a while. Well, we've also seen how an if statement can have an else clause, like you see here. We understand how this works for if statements. Well, guess what? We can do the same thing for while statements. Again, the only change is that the word if changes to while. And what happens now is that we check the conditional, and if true, we do the body of the loop, and then check the condition again. And this will continue as long as the condition is true. But whenever the condition becomes false, we then execute the else part of the statement. That's true whether it's the first time we check the condition or the 1000th time. Once it's false, we do the else part. After the else part, we're all done though. We don't go back through the loop anymore. So, the code that we see here will keep asking for a value until we get something greater than 0. Once we do, whether that's the value when we start out or that's the value we end up at, we then output a statement, you entered some value. If you remember our if statements, we could put an if inside of another if. We called this nesting. Just like we had nested if statements, we can also have nested loops, where one loop is inside of another. Here's an example for printing out the times tables. First, we have a loop using I to count from 0 to 9. Now, for each value of I, we'll go through another loop, this one using j to count from 0 to 9. For each combination of I and j, we'll output one line, saying I times j equals the product of I and j. So, this loop will print out a multiplication table for all the numbers from 0 to 9. Let's say that you wanted to modify the code to make the times tables run 1 to 10 instead of 0 to 9. How might you do that? Well, one of the simplest ways is to change the range to be 1 to 11 instead of 10. That will ensure that each loop begins at 1 and goes on as long as it's less than 11, instead of as long as it's less than 10. A different way to achieve the same goal would be to leave the loops themselves unchanged, but change the values that are printed, basically replacing I with I plus 1 and j with j plus 1. So, although the loops would still go 0 to 9, the printout would show 1 to 10. Let's look at one more example. Imagine that you have a number of people and you want to print out a list of every possible pair of people. You only want each pair once though, so pair AB is the same as BA. Do you see why this is a good problem for nested loops? You have an outer loop for the A member of each pair, and then a second inner loop to get the remaining members available for the B member of each pair. Let's assume we've read in the number of people into a variable numPeople. How might you use nested loops to print out the different pairs, where a pair has the number of the first person and the number of the second? Here's one way of creating these pairs, using nested loops. First, we have our outer loop, in which I ranges from 1 to numPeople. Notice that the range to use is 1, numPeople plus 1. That ensures that we start at 1 and we include numPeople. Our inner loop needs to start with the person after person I. Notice that person I will have already been paired up with the people with an earlier number, when that person was the one in the outer loop. So, we only need to pair person I with the people with a number greater than I. Our inner loop, therefore, starts at I plus 1, and goes again all the way through numPeople plus 1. Let me mention a couple of optional commands that you can add to loops that'll sometimes make your code more efficient and look a whole lot cleaner. The first of these optional commands is called the continue statement. Sometimes you have a complicated loop with a lot of stuff going on inside. In this example, all I want you to notice is that it's going through a loop, and it's got an if statement inside that's trying to get us to skip certain dates. Basically, the loop is doing something, but when day is a multiple of data skip, it skips part of the loop. Now, looking at this code, there's nothing wrong with it, but it's got a couple of aspects that aren't ideal. For one, there's a lot of indentation. Indenting is fine when needed, but unnecessary indentation can make it harder to read the code. And second, the indented code isn't that different from the other code. It's not as though it's part of an inner loop or some rare branch of the code. In fact, it's the more typical branch. So it might be nice to have an alternative way to write this. All we do is indent in a continue statement just below the first conditional, which we also change from a not equal to an equal to. This code does the same thing as the previous code. What the continue statement does is tell the computer, I'm done with this iteration of the loop. Let's skip to the end. It's a way of skipping everything else in the body of the loop that you're in and going back to the beginning. In this case, we can put in a check to see if we're on a day that we want to skip, and if so, we just go on to the next iteration of the loop. We skip all that other stuff. So in short, the continue statement offers a nice alternative for writing a loop, allowing you to skip through an iteration of a loop without adding in another layer of indentation for a large chunk of code. One other optional loop command that can make your life easier is the break command. Break is like a more extreme version of continue. Break says, I'm done with this loop for good, get me out of here entirely. When you encounter the break statement, you immediately exit the loop. You even skip the else part of the loop, if there is one. In this example, we're looping through a set of numbers, printing them out. And if we get through all of them, we print a message saying, we got through all the numbers. But if we encounter the, quote, bad number along the way, we print out a message and exit the loop entirely. Notice that the for statement starts at 1 and increments by 2's as long as the iterator is less than 10. If we were to look at the output of this loop, we'd print out 1, then 3, then 5, then we'd hit 7, and we'd just output the error message and stop. Notice that we don't continue, and we don't execute the else clause of the loop. On the other hand, we could have a different loop, where we start at 2 instead of at 1. In this case, we'd get through all the numbers, never hitting the number 7. And eventually we'd print out the got through all the numbers message from the else clause. A break command is a good way of getting out of a loop when you might otherwise encounter a problem, or when you've reached a point that you know you're all done. Again, both continue and break commands are optional. You never need one. But they can be useful tools to clean up your loops, both for loops and while loops, and avoid spending more time in them than is needed. Keep in mind that these will only break or continue from one loop. If you have nested loops, they'll only let you break out of or continue within the innermost loop that the statement's a part of. So, think of loops whenever we need to get a bunch of input, or generate a lot of output, or just do any action over and over again. The for loop is the choice when we have a well-defined set of items to go through, or a clear number of times to run through the loop. If we're a little uncertain of how many times we'll need to repeat a loop, but can clearly define when we'll be done, that's the time for a while loop. If we know we'll be taking 1,000 steps, we should be using a for loop. While if we know we're just taking steps until we reach our destination, that's the time for a while loop. Loops save us lots of time, but an even bigger advance is never having to retype our data or retype entire programs at all. And this brings us to the very useful topic that we'll explore next time. That's the subject of files. Let's use a loop to explore an interesting mathematical problem. The Collatz conjecture, or 3n plus 1 conjecture, says that given some number, there's a pair of manipulations that can be repeated until it eventually will reach 1. The manipulations are given by two rules, depending on whether the number is odd or even. If the number is even, you should just divide it by 2 to get the next number. If the number is odd, you multiply it by 3 and add 1 to get the next number in the sequence. So, go ahead and try to write code that will generate this sequence for a given input number, and tell you how many steps it took to reach 1. First, read in the number from the user, and then generate the sequence for that number. Here's some code to do this. We'll start by reading in the starting number n, and we initialize the count of the number of steps to 0. Then we have a loop. The loop will continue as long as our number n is not 1. Inside the loop, we increase our count of the number of steps, and then we generate the next number in the sequence. We determine whether the current number is even or odd by using what's called the modulus operation, for which we use the percentage sign. And this operation will give you the remainder when the first number is divided by the second. So, if we take a number modulo 2, we'll get either a 0 or a 1. If the answer is 0, it must have been even. And if the answer is 1, it must have been odd. Now, depending on whether the result was even or odd, we generate the next number in the sequence by either dividing by 2 or multiplying by 3 and adding 1. Either way, we print out the result. And the loop will end when the sequence finally gets to 1. And at that point, we can print out how many steps it took. That's all there is to it.